Okay, welcome to the next video in the systems programming video series. We have, we're still working on week 6, and we just finished reading the reading assignments, and so we're going to move on to the programming assignment. So in this, we'll start with 4-letter words. So in the program, word.c implement a program that asks the user for a 4-letter word and stores the characters within a single unsigned int. So we can see that when you call the program, it will ask you for a word. It then proceeds to take every single character, and I guess it's doing this in reverse order. I'm not sure how important it is to do it in reverse order. So if I accidentally do it in regular order, I may not be too, oh, but I guess the E should go at the end, and that's what we're seeing here. So, right, so E has characters 65 and V presumably 76 and so on, all written in hex, right? Keeping in mind that each char takes up 1 byte, each hex code or symbol or whatever takes up 4 bits, which is half of a byte. So right, so the 6 is a hex digit, the 5 is a hex digit, 2 hex digits make up a byte. So this is 1 byte, and unsigned int takes up 4 bytes, right? So 1, 2, 3, 4 bytes. So anyway, so basically what we're doing is we're putting the hex code for E into the last byte, the hex code for V into the second to last byte, the hex code for O into the third to last, and then the last for L. And then what it does is it says that your number, I guess this is taking that right, like once you've coordinate-wise assigned all the hex codes, then we are supposed to print out the single number written in base 10 effectively, which is equivalent to that, so to speak, right? And then we also write out its final hex code, which you can see by like sort of putting the 65 together with the 0 together with the 0 together with the 0. Then when you sort of like add them all together, you get this 65, right? And then likewise, the 76 here comes essentially from this added together with a bunch of zeros within that byte address. Okay, so there's a description of the project. And so now let's come over to the code. You can see that here's the assignment. Yeah, here's the assignment directory. And I believe, yeah, this is in word.c. I'll import my libraries. You can see here that I have written my initial implementation of this thing, which I will now comment out, and we'll build it from scratch. So the first thing I need to do is I need to get a word from the user. Before I get the word from the user, I have to malloc space to hold it. So char star word equals malloc size of char times 5 for the 4 letters and the null terminator. So then I want to request from the user. So I'm being increasingly lazy, and I'm just going to give very terse instructions to the user. So now I have the input from the user. I guess, if I wanted to, do some like, defensive programming, I could like check to make sure that there are precisely 4 letters, and I, I want to get on with it. So now I want to take these 4 letters and basically process them character by character, and I'm gonna ultimately accumulate them into an unsigned int. There are other ways to, like, you could basically like take each char and get its corresponding 4-byte, a variable storing 4 bytes that has that char in the correct location or something like that. But the way I'm going to choose to approach this is to take the unsigned int, just call it a, whatever, just some number, initialize to 0, because I want to be sure that it really is all zeros to begin with. And then I want to progress through the letters. And it does kind of occur to me, so right, I don't think I did this in my initial implementation, but maybe I do really want to make sure that I progress last letter to first. So let's actually do a for loop for int I equal to 3, I 0 less than or equal to I minus minus. And now what I want to do is I want to take this letter and I want to, I guess the first thing that I'm thinking I'm going to do is I'm going to print it. But then how do you print it? Because it, I mean, like I can turn it into its corresponding hex. That can be done with a format string. But how do I pad it with the appropriate number of zeros, right? Because when I print its hex, it's just going to be 2 digits, whereas what the assignment wants is padded out with an appropriate number of zeros. So to pad it out with the appropriate number of zeros, then I'm going to say for int j equal to 0, right? J is basically going to give me, in some sense, count out how many pairs of zeros I want to print in the appropriate place. So j is going to go up to 4 and increment. And so what I want to do is when I is equal to 3, I would like to print 3 pairs of zeros and then print my hex code for this ith character in the word. Basically, if I is not j, then I want to print a pair of zeros. Else, I want to print the hex. So this is how you print a hex for my char, which is word at I. So that prints out, oh, and I guess, if I want to, I can go ahead and say, print f, or maybe I would do that actually up here, print f the hex of, and I'll say %c for the char is, and then a line break be percent, oh, right, and not a line break yet. And so then I want to say word at I. And then at the end of the for loop, I want to print a line break. Okay, so I think that prints all of the hexes. Now, besides printing the hexes, I also want to accumulate the sort of all of the values bit shifted in the appropriate ways. So let's say that I want to A or equal the bit shift by 4 minus I, right? So when I is equal to 3, I want no bit shift. When I is equal to, or sorry, not, well, yes, a bit shift. Anyway, yeah, so when I is equal to 3, I want no bit shift. When I is equal to 2, I want to bit shift by how many bits? Well, 1 byte, so I should shift by 8 bits. So, right, and so every time I decrements, the number of bits increments by 8. So effectively what I'm getting at here is that I would like to OR it with the value of word at at I bit shifted by 8 times, what is it, 3 minus I. So I think that should do it. I'm doing this slightly differently than I did the first time, so I hope that works. And then at the very end of the run, I want to print the result, which is I'm just going to put the number %d, which is %x, given by a. So right, I want to print its decimal representation and its hex representation. This might be everything. So if I malloc anything, oh right, by the way, if I malloc anything, I should always check whether it works. So not that this ever, when things are this small and basic, they never go wrong, but let's just do it out of principle. And then free whatever you malloc, null the pointer, and return 0. So make word, it did it. I removed, by the way, because I just found the crashing on air on warnings to be too obnoxious, so I removed that from the make file. But so make word, and then I want to run word get ABCD. The hex Oh yeah, nice. And it's in reverse order. The hex of D is this, which is believable, right? So the hex of A is 61, I guess. B is 62, 63, 64 for the following things. And they are printed with the appropriate padding in the appropriate places. Oh, I guess I could have put a line break here, but not that that super matters. Then I get the numeric representation, the decimal representation here, and the hex representation here. And you can easily see that the hex is correct because it goes 61, 62, 63, 64. So success.